This is Mr. Campbell. This is Algebra 2, 2.1 vertex form of quadratic functions. Notes for the homework. It's the first unit in topic 2. We're going to be talking about quadratics. And a quadratic function is in the form of ax squared plus bx plus c. All quadratic functions are transformations of the parent function, which we've already talked about, f of x equals x squared. The graph of a quadratic function is called a parabola. The vertex form, which is what we'll be doing mainly in this section, the vertex form is a times x minus h squared plus k. So that's, or transformational form. It's the same thing. It's the same thing we've been talking about. H is our shifting right and left. K is our shifting up or down. A tells us if the parabola is opening up or down. And it also tells us if it's a stretch or a shrink. That's what we'll be talking about. Vertex form is useful because it highlights the vertex of the quadratic function, which is key in graphing it. F of x equals x minus h plus k, where hk is the vertex. If a is negative, the graph reflects over the x-axis. If the absolute value of a is 1, the graph has a vertical stretch. So if a is greater than 1, absolute value, if the absolute value of a is less than 1, the graph has a vertical shrink. Or you could say compression. Either one means the same thing. Parabola is the graph of a quadratic function. The vertex of a quadratic is h comma k. And of course, we've already talked about this. This is the equation in vertex form, which is a times x minus h quantity squared plus k. So this first one here, so the graph of a quadratic function is called a parabola. And in vertex form, h comma k is f of x, or the f as a function of x is a times the quantity x minus h quantity squared plus k. So it asks on the first one, what are the transformations of the parent function x squared to g of x? Okay, if you remember, we always start here. So first, since a is negative or less than 0, since a is negative, it opens downward. Like this, right there it is. So it opens downward. Because negative 1/2 is less than 0. And another thing you could say, since we have a negative there, that means it's reflected over the x-axis. Then it's vertically compressed by a factor of 1/2. Remember, the absolute value of negative 1/2 is 1/2, which is between 0 and 1. If it's the absolute value is between of negative 1/2, which is 1/2, since it's greater than 0 and it's less than 1, it's compressed, and then you're shifting the graph left 2. So it asks, what are the transformations of the next one here, this one here, example 1b. So first, since A is greater than 0, it opens upward. So A is positive. So since 2 is greater than 0 or positive, it opens upwards. Again, I'll put it right here for you. 2 is greater than 0, which means it's positive. Okay? Then 2 also tells us, since 2, the absolute value of 2 is greater than 1, it is a vertical stretch by a factor of 2, and you're going to go right 1. Remember, it's an imposter inside the parentheses, and then down 3. So right 1, down 3. This next one here says, describe the transformations of the parent function from f of x, which is x squared, to g of x, which is the opposite of the quantity x plus 2 squared. So since a is less than 0, which means it's negative, a is less than 0, which is negative, and again, it is negative, then it opens downward, which means it's reflected across the x-axis. Reflect across the x-axis, which means it opens downward. We just talked about that. Opens downward. So if this thing is negative, it's going to open down, which means the vertex is going to be a maximum. If it's positive, like this one up here, this one here was positive, that means it's going to open up, and the vertex would be a minimum. And then this one here is shifted left 2. Okay, so the only transformations was reflected across the x-axis, and it was shifted left 2. This next one here, describe the transformations of the parent function, then graph the function. Notice there's nothing in front, so it's going to have the same shape as the parent function. So there's no reflecting, there's no stretching or shrinking, but this here tells me it's shifted right 1 and up 2. So right 1, up 2. Okay? Okay, the next one. What are the key features of this quadratic function? So the key features are this. The 2, this right here, indicates the graph opens upward. Why? Because 2 is greater than 0, which means it's positive. Opens upward. And since the absolute value of 2 is greater than 1, then it's stretched and is stretched vertically. The range, which you remember, the range is floor to ceiling, so the vertex was what? 3, 4, so it'd be something about right here. And I know it's going to open up, something like this. So the range would be the floor to the ceiling. Well, the floor is always going to be that right there. So the range is going to be y is greater than or equal to 4. So you could say it's from 4 included to positive infinity. So this is inequality notation. This is interval notation. And the domain with these parabolas will always be these quadratics. When I say parabolas, I mean quadratics, is all real numbers. You can write it like this in interval notation. Okay, so this next one, let's go through it here. The vertex, remember that's an imposter, so the vertex is always written h comma k, so that would give me -4, -5 for the vertex. Now, we haven't talked a lot about the axis of symmetry, but the axis of symmetry always goes to the vortex and is equal to x. It's a vertical line at x equals h. So the axis of symmetry would be x equals -4. Now remember, this is negative, which tells me it's going to look something like this. It's going to open downward. So my vertex, this thing here is going to be a maximum. So it's going to, so when a is less than 0, which means a is negative, in this case it was -1, when it's negative, when a is less than 0, it's going to be a maximum, your vertex. When, and just like this one, if it's less than 0, which means it, or excuse me, greater than 0, which means it's positive, let me erase that. When a is greater than 0, or positive, it will be a minimum. And again, if you remember, the domain for all quadratics is all real numbers. So the domain is -infinity to infinity. You could say the double bar r's. And the range, okay, so this one here, this is going to always give me your range. Now, the problem is it going to be -5 to infinity or -infinity to 5? Remember, though, it's going to this one's opening down, so it's got to be -infinity to -5. So your range is -infinity to -5 included. So you could say x, or excuse me, not x, because range is your y, right? So y would be less than or equal to -5. Either way would be correct. Move this up. Move my water. Okay, this one here says, what is the equation of the quadratic function with vertex of -2, 3 and a y-intercept of -1? So here's vertex form. To write it in vertex form, you're going to need to know A, H, and K. Well, we have it in vertex form. We already know H and K. And they give us a point on the graph, which is the y-intercept of 0, -1, which is right here. So that's the point 0, -1. So what we do is we plug in for our y, which in this case would be -1. A is what we're trying to find. That's what we don't know. X is 0. And what I like to do is, like our h comma k, here's our h comma k. I like to write it like this, h, k, and then the point on the parabola, which was the y-intercept, is 0, -1. I like to write above it x comma y. So I'm going to plug those four variables into this equation, and solve for a. So y is -1. A is my unknown. X is 0 minus a -2 squared plus k, which is 3. So we got some simplifying to do. So a negative of a -2 is +2. Squared would be 4. And take this 4, so I got 4 for this whole thing right here, and put it in front. Don't take 4 plus 3. You don't, it's a4, but you put the 4 in front. Don't add the 4 and the 3. So the 3's right here. So I got, for this thing right here, I got 4. Negative of negative means +2. Squared is 4. And then I put it in front. And then I bring my 3 down. So now I'm going to subtract 3. Cancel, cancel. So it gives me -4 equals 4a. And then I divide by 4. So a is -1. So now I've got it. There's A, and we already have our vertex, which is -2, 3. Remember, H comma K, H and K. So we can write our equation. I'm going to put it right over here on the side. Y equals A is -1 times X minus a -2. Remember, it's an imposter. X minus a -2 squared plus 3. And they'll probably write it like this. They won't write -1 in the front. So there's your equation in vertex form. The next one here. Again, it tells you the vertex is 1, -4. So I'm going to write that H and K. So it just reminds me. And then we got a point on the parabola, which is, I'm going to write it x and y. So my equation in vertex form is y equals a times x minus h quantity squared plus k. So I need to know a, h, and k. Well, I know h and k, and I don't know a. So I'm going to plug in these four variables and solve for a. It's my unknown. So y is -1. See, I like to label these so I know which one it is. Equals a times x is -2 minus 1, because h is 1, squared minus 4, because k is -4. So let's do some simplifying. -2 minus 1 is -3. Squared would be 9. And remember, put the 9 in front. Now I can solve for a, add 4. So it gives me 3. 3 equals 9a. I'm going to go right here. So 3 equals 9a. I divide by 9. And I get 1/3 for a. So I've got 1/3 for a. And I know my vertex, which is right here. Now I can plug it in. So y, I'm going to do it right here. Y equals a. We found it to be 1/3. And then there's h and k. So it's an opposite, x minus 1 squared minus 4. So this one here would be a vertical compression of a factor of 1/3. Shifted right 1, down 4. Example 4. I'll move this for you. This is the height of a thrown ball of a quadratic function. There we go. The height of a thrown ball of a quadratic function of the time t has been in the air. The graph of the quadratic function is the parabolic path of the ball. The vertex of the graph is 120. So my vertex is 1, 20. So that's h, k. Okay? So you got 120. Right there it is. 1, 20. All right? Then it says, and the path of the ball includes the point 0, 4, which is the y-intercept, 0, 4. Okay? What is an expression that defines this function? Write the quadratic function in vertex form and then in the form ax squared plus bx plus c. This is called standard form. So we're going from vertex form to standard form. So let's first put it in vertex form, which is y equals a times x minus h squared plus k. So remember, and then we know the point that was on the graph is 1, 20, and I like to label these, okay? I like to label them, so I'm going to plug them in. I got to find a. So y is 20, a is my unknown, x is 1, h is 1, so minus 1 is an imposter, plus 20. Okay? So that's not correct. I made this the vertex, didn't I? Caught my mistake. Sorry. It's late in the afternoon. Okay? So the point on the graph was the y-intercept, which was 1. No, it wasn't. It's 0, 4. Excuse me. 0, 4. That's x, comma, y. So now we can plug it in. So y is 4. A is my unknown. X is 0 minus 1 squared plus 20. So 4 equals, this gives me negative 1 squared. Well, negative times negative is a positive, so I get 1a. So I like to put that 1 in front. I don't get this and add it to that number there. I don't. Whatever I get for this, I put it in front. So then I subtract 20. So I get a equals negative 16. So now I know a is negative 16. Okay? So I can write my equation in vertex form. Here's vertex form. So y equals negative 16 times x minus 1, quantity squared, plus 20. So we have it in vertex form. Okay? But we want it in standard form. So what you're going to do is this. You're going to square this. So we're going to have to take x minus 1 times x minus 1 and then multiply that by 16. Okay? So I'm going to do that out to the side. X minus 1 times x minus 1. Okay? That means the squared. So FOIL method, right? X squared, negative x, positive 1. So when I combine like terms, I get y equals negative 16 times x squared. This gives me negative 2x when I combine these two together, plus 1 plus 20. So this whole thing here, we multiply it out by the FOIL method. Remember, first, outside, inside, last. So really double distributive. Now we're going to distribute the negative 16. So it gives me negative 16x squared plus 32x minus 16. I'm going to bring my 20 down. Now my last thing, all I have to do is combine these two together. So that gives me y equals negative 16x squared plus 32x. Negative 16 plus 20 would be 4. So there it is in standard form. Okay? So here's vertex form. And here's standard form. Vertex form is much user-friendly. Okay? Let's do another one here. Okay, so this one here, they want you to go from vertex to standard. So my vertex of this parabola is 2, 10. Okay? 2, 10. And the point on the parabola is 0, 4. Zero, 4 right there. So remember, vertex is h and k, and the parabola is x, y. So I'm going to plug it into vertex form. Put it in vertex form first. Some places call it translation form. So we're trying to find a again. So y is 4, a is my unknown, x is 0, minus h, which is 2, squared, plus 10, because k is 10. So negative 2 squared would be 4. Remember, put that 4 in front. Don't add it to 10. Don't put 4 here and then add to 10. Put it in front. And then now we're going to subtract 10. So we get negative 6 equals 4a. Divide both sides by 4 and reduce that fraction so I get negative 3/2 for a. And notice this is negative. Notice how it opens down. A has to be negative. So here it is in vertex form. Y equals a, which is negative 3/2, times x minus h, which would be x minus 2, quantity squared, plus 10. There it is in vertex form. Okay? Agreed? I reduce this fraction to negative 3/2, and then now I have it in vertex form, and I need to get it in standard form. So what I have to do first is FOIL this thing out. So I'm going to do it right here for you. X minus 2 times x minus 2. So first, that's x squared. Outside, so this was the first. Outside would be negative 2x. Then inside would be negative 2x. And then last would be a negative 2 times negative 2 to a positive 4. When I add those together, I end up getting x squared minus 4x plus 4. So now I'm going to write it like this. Negative 3/2 times this right here is equal to that. So I get x squared minus 4x plus 4, and I have my 10 too. Okay? So I have to distribute here. So y equals negative 3/2 x squared. Now when you take negative 3/2 times negative 4, that would be, take negative 3 times negative 4 is 12, positive 12, right? Because a negative times a negative 12 divided by 2 would be 6x. And then 3/2 times 4, negative 3 times 4 would be negative 12 divided by 2, which is negative 6. And then I'm going to bring that 10 down. Okay? So I can combine these two together. So in standard form, it would be this. Negative 3/2 x squared plus 6x, and negative 6 plus 10 would be 4. So there's standard, and there's vertex. Here's standard. Okay? And here's vertex. Okay? Now, it says this, the function g is a translation of the parent function f, 1 unit left and 3 units up. What is the equation of g? Write the quadratic equation in function form in the form f of x equals ax squared plus bx plus c. So they told you that the function f is shifting left 1. So it's f of x plus 1, correct? If you go left, remember it's an impositor, and then it says, and 3 units up. So 3 units up would look like this. Okay? So then the new g of x is going to be this right here. F of x plus 1 plus 3. Okay? So g of x is equal to a, we don't know, times x plus 1 quantity squared plus 3. So again, we have to find a. We do know, here's g, there's a point on the graph of 0, 4, right here for g. 0, 4. So we've got the point 0, 4, x and y. And we know the vertex, h and k, is negative 1, 3. H and k. So we're going to plug it into our, we're going to have to find a now. So we're going to have to plug in here. So we remember g of x is the same thing as y. Remember, y is 4. A is my unknown. X is 0 plus 1 quantity squared plus, let's see here, y is 4, x is 0, my vertex would be 1, correct? Plus 3, okay? So 0 plus 1 would be 1 squared, so that's just 1, 1a, right? 1 squared is 1, plus 3, then I subtract 3, so that gives me a equals 1. So in vertex form, it's going to be g of x is going to equal to 1 times x plus 1 quantity squared plus 3. I'm probably going to write it like this without the 1 in front. You should already know it's there without writing it. Okay? There is vertex form. Okay? Vertex form. And they want to change it to standard form. So I'm going to have to FOIL that x plus 1 out quantity squared. I'm going to do it right here. X plus 1 times x plus 1. So first gives me x squared. Outside gives me an x. Inside gives me an x. Last gives me a 1. So when I combine these two together, I end up with g of x equals x squared plus these 2x plus 1. So that's this. And I got to bring my 3 down, and I add the 1 plus 3, which gives me x squared plus 2x plus 4 in standard form. There it is. So standard and vertex form. So it's easy to go to from vertex to standard. A lot more difficult to go from standard to vertex form. Okay, ask you this. It says, given that f of x equals x squared, write the equation in both vertex form and standard form that satisfy the given following transformations. Okay, so let g of x be a quadratic function whose graph is translated 2 units right and 5 units down of the graph of f of x. So g of x would be 2 units right, would be x minus 2 squared, because remember it's an imposter, minus 5. There's vertex form. But they want it in standard form. So g of x is equal to, I'm going to have to square that x minus 2, which is x minus 2 times x minus 2. So x times x is x squared, negative 2x, negative 2x, positive 4 when I use the FOIL method. So I combine these two together. That gives me x squared minus 4x plus 4. And of course I have the negative 5. So this is this. Then I combine these two together, so I get g of x is equal to x squared minus 4x, and 4 minus 5 would be negative 1. So there's vertex form, standard form. And then we already got vertex form. So it's easy to go from vertex to standard. A little more difficult. We'll learn how to go from standard to vertex later. Okay, then it says this. Let h of x be a quadratic function in which graph is reflected of the graph of f of x over the x-axis, followed by a translation 1 unit down. So we know if we have this right here, correct? So there's no shifting right or left. So it's x minus 0. If you just want to write x squared, that's fine. And 1 unit down. So it'd be minus 1. So right now we have this. This here. So there it is in vertex form. You probably will write it in vertex form more like this. And then this here would be standard form. So vertex form here and standard form here. Okay? Now it asks this question. What information do you need to write the equation of a transformed quadratic function into vertex form? You need to know the value of the vertex and at least one other point on the transformed function. So you need to know a point and you need to know the vertex. Okay, here are the things that we just talked about that you might look over, but the graph of a quadratic function, of course, is called a parabola. A quadratic function that could be expressed in vertex form is this right here. Vertex form shows that there's different ways in which the graph of the parent function can be transformed. When it's written in this form, the vertex, these here are things you'll figure out as you do that. Okay? So, again, the graph of a quadratic function is called a parabola. Vertex form shows the different ways in which the graph of the parent function can be transformed. Again, the parent function, which is here, the vertex is 0, 0. Axis of symmetry is x equals 0. Remember, the axis of symmetry is always x equals h. This one opens upward because a is positive. And since it opens up, because it's positive, then my vertex will be a minimum at y equals 0, because the minimum is always k. Y equals k is your minimum. And your domain, if you remember, is always all real numbers. And the range, if it opens upward, will always be k to positive infinity. In this case, since the vertex is k is 0, it would be 0 to infinity, 0 included. When it's translated, again, a cannot be 0. Your vertex is h comma k, which we've already talked about. Your axis of symmetry is always x equals h. Your domain is all real numbers. If a is positive, it opens upward. When I mean opens upward, it's going to look like this. Therefore, the vertex is a minimum at y equals k. And your range is k to infinity. Here, if a is negative, it opens downward. Opens like this. So your vertex is a maximum. Again, your maximum will be a value of y equals k. And the range is floor to ceiling, so it'd be negative infinity to k. Okay? Let's move on. Essential question it asks this: how does the equation of a vertex in vertex form, this is how does the equation of quadratic in vertex form